So, hi everyone. Salam alaikum. So, for today's session, we have as a guest Mrs. Ilhem Bekkar, and our topic is about using AI agent to production. So, I let Ilhem Bekkar with her presentation for now.
Thank you very much for the invitation. Thank you very much for the introduction. Thanks to School of AI for this AI summit. It was a real pleasure to follow you during the previous sessions. I really enjoyed the sessions, the topics, and the guests. It was really informative. Thank you very much. So as you said, for today, we are going to talk about AI agents, but more into how to take them into production. So before, let me share my screen. I think it's already shared, right? Okay. For me, I'm Ilham Bekkar. I'm an automation and Gen AI engineer at Sura Labs. So basically, we are working on leveraging generative AI and especially AI agents into production for companies from different backgrounds and different specialties. My interest for now is to bridge the gap between the cutting edge research and the ready to use AI products. So I'm between AI agents, MLOps, and AI systems. All right, perfect. So to start with, I'm going to share with you some statistics that are saying that the future of AI is agentic. To start with kind of the big picture of the agentic AI that is moving very fast. I believe that it's not just a hype. It's because there is a reason after all this hype. It's automating a lot of complex tasks, enhancing real-time decisions, and reshaping how business operates. We found that there is a rapid market expansion in agentic AI that started only I can say last year, and for this year we are expanding. I mean, the market is going to expand into $2.27 billion around this in the US, and we are expecting another expansion of 43.6%. It means by the year of 2034, we are forecasting a market size of 58.9 billion dollars in the agentic AI field, for the customer services and logistics to healthcare to finance, etc. So those AI agents are really used, and they found a real success in cross sectors uh, shell, I would say. And this success was, it was a fruit of the success of the LLM advanced, because agentic AI is built on top of the LLMs. So it was something that we are waiting for. So I would say the AI agents are the next generation of the LLMs. At the beginning, we started with models that were pre-trained or trained on knowledge. They know only what they were trained on, and then we tried to add a kind of memory. So we found ourselves in rags, and then now we are taking it into an agentive framework. We will talk about it in the next slides. So some insights about the market impact and the consumers insights. So first of all, the enterprise software integration. We are we are I mean we are in a position to say that by 2028, according to Digital Delph Agentic AI statistic report, 33% of the enterprises are going to apply agentic AI into their systems, and especially the SE systems. So they are using those agentic AI techniques to boost their operational efficiency, and it's going to boost it by 30%, as they said. Now, for the business confidence, and actually, it's an amazing number. 90% of the companies, they believe in agentic AI. Sorry, and of course, after only 2 years, you get a belief from the business by 90%. I think it's something huge, and even the customer acceptance. So customers are accepting to use or to engage with AI-powered applications by 65% of them. Now, we have seen the importance of all those of this field. Let's say, what are AI agents, if we can say? Sorry. So the AI agents are kind of applications or systems that are engineered to achieve a special objective. How? So basically, we have an environment, and our agent is going to perceive this environment and do some strategical actions upon it. So using the tools that it contains in its disposal. So according to this definition, we will understand that the agents are basically composed of three main components. The model, who is going to act kind of the brain of this agent. It's the central decision maker. It's going to act on the top of the environment to do either the perception, the reasoning, the planning, and taking actions. And then by the end, if you want to have an answer, you have the tools which are the external capabilities that will provide some additional functions to this model. So the model is not, let's say, a dead model. A dead model, what do we mean by dead model? Its knowledge is just based on what he knows before. So here we are trying to make things more interactive. We have, and the tools can be extensions, functions, or data stores. By extensions, I mean a kind of a bridge between the model and the APIs that we can put into inside this environment. So the agent will use those APIs through the extensions. We have the functions, which are just the functions that we know, self-contained modules of code that accomplish a specific task, and we put them inside the environment as well for the model to use them. And the data storage, they provide access to, let's say, an up-to-date information or a database. Or what I mean by an up-to-date information is that information that we bring through the APIs, and then we have intention to store it and then use it another time. And of course, those data stores, they can be persistent as they can be kind of short-term data stores. And the third layer is the orchestration layer. So this orchestration layer is a cyclic process that will dictates how the agents assimilate the information, how it's going to engage with the internal reasoning, the planning, and how it's going to leverage this reasoning to inform the subsequent actions and decisions by the end. So this layer is responsible for maintaining, I would say, everything: the memory, the states, the reasoning, and the planning. Maybe we go to the previous. Yes, here. So this is the orchestration layer, and it contains basically the memory, how the model is going to reason and the plan, and as well as what are the goals, what are the instructions, etc. So to have a small example or to put everything together, the process is going to be something like this. So we will get a query. This query is a prompt, and then the agent will get this prompt. It's going to use the tools that exist in the environment, and it's going to define the most suitable tools for this prompt. And then, of course, the definition is going to be after the reasoning and the planning using the model. And then it's going to have another prompt to launch those tools. Once we get the answer from the tools, we will reason an answer, and then we will send it again into the customer UI. So basically, this is a big idea of, or the big flow. Now, since we are going to be interested into the production side of the agents, so we will find ourselves talking about something like agent ops, if you want. So something that contains the word operation. So actually, over the past years, especially the past 2 years, we had many ops words. So we had the Gen AI ops, the ML ops, the FEM ops, the LLM ops, and now the agent ops. Basically, they inherited their meaning from the DevOps. So we will have always the same notions from the DevOps, they all share the core capabilities, like version control, CI/CD, the testing, the loggings, the security, the metric monitoring, etc. So all those, it means if we are adding something or another layer, we are not getting right from the previous concepts. We always keep the previous concepts and then add another layer on top of them that is more specialized to the topic that we are talking about. So basically, we have the MLOps here. The MLOps was more into the model development. So when we are in the loop of developing our model, and I mean the ML models in general. And then when we talk about the application side, we are more talking about the Gen AI ops. And here we have some subcategories. We will find the agent ops there. Now, what do we mean by agent ops? So, as I said, we will inherit what we have as concepts from the DevOps, but we will add some special things related to agents. For example, the agent orchestration, the memory orchestration, the task decomposition, because sometimes we send the task and it's not detailed or decomposed. Then the agent should do kind of reasoning and planning inside to decompose this task and then go through using one of the techniques, for example, a chain of thoughts or something like that. As well, another topic that we will have as well in the agent ops, we'll find the tool integration. So the tool integration is more code talking. Let's say, how are we going to integrate the tools, the internal ones and the external ones, etc. How are we going to structure our code, the protocols that we need to use, etc. And one of the topics that we talk about as well in this special field, we have the agent evaluation, which is one of the biggest topics that we are going to talk about it in details in this presentation. So for the evaluation, it's kind of bridging the gap from the proof of concept to production. So it requires kind of a robust and automated evaluation of the framework, because your framework is in production, and you need to keep track of the performance of your model. So unlike generative models, the agents evaluation will focus more on understanding the decision-making process and the structure around the three key components. So the key components are the model, the tools, and the memory, if you want, or how are we going to orchestrate all the components. So we will find three main let's say, techniques to evaluate. The first one is assessing agents' capabilities. What do we mean by this? Evaluating the agents inside its environment. It means how this agent is understanding the query, how it's trying to reason and do a planification for its work. And the second one is evaluating the trajectory and tool use. So how the agent is using the tools. Sorry, is it using the right tool? Do we have some hallucination in the choice of the right tool to use? Hallucination is more used with the meaning the meaning of the answer, but we are more into hallucination of choosing the right tool. And finally, evaluating the final response, or yes, the final response, which is evaluating the quality, the relevance, and the correctness of the final outputs. Okay, so here when we talk about the first one, which is assessing the agent's capabilities, so we have some benchmarks that we can rely on. So, for example, here I'm putting the agents bench, which is a benchmark shared by, to be honest, I don't remember the laboratory, but it's one of the well-known laboratories. So they try to have an evaluation of 26 large language models, and how do they act on different scenarios or different real-world challenges. And then they had this benchmark that you can use at the beginning. For example, let's say you are going to take Gemini as an LLM, and your topic, for example, is web browsing. Let's say web browsing. So you want to know the performance of your model in web browsing at the first or as a first idea. You can use the benchmark for it, but I mean, after this, you will not stop here. Of course, you will try to write your own tests on your use case for your model, and then, of course, you will get something more adapted to your case. The second one is evaluating trajectory and the tool use. So here, basically, when you look on the process of execution, the execution of the agents, you will find that we have many many actions, and those actions are going to form a trajectory. That's what we call by a trajectory. So, for example, here you will ask a question, and then the model is trying to decide which is the tool to use. So this is the first action. And then once we decided the tool to use, we will launch the first action, and we will get an answer. For example, here, we will get an answer back. This is the second action, etc. This is what we call a trajectory. And here we have 6 ground truths that you can take them into consideration. The first one is the exact match. Before going to those ground truths, so basically you have the execution trajectory, and you have something that we call the previous or your let's say your imaginary trajectory, if you want. So you imagine a trajectory and you put it as a ground truth at the beginning. So you compare yourself to this trajectory. You see, the human is always inside the loop of evaluation, but it's one of the techniques. And then you try to compare the ground truth, the human ground truth trajectory with the execution trajectory. So those are the matrices, if you want. So the exact match is the agents replicating the ideal sequence that you put it at the beginning, or there is some deviations in order match. Are we using the steps in the correct order or not? Any order match, for example, we are using the same steps but in different orders. The precisions, we measure how many predicted actions are relevant and correct compared to the reference. The recall, precision and recall, mainly you know them, but here they are applied more into the actions of our model. And single tool use, for example, if you are your agents, you try to check it if it's using correctly the specific tool within its action sequence or not. So here, mainly, you feel them, if you are from a development background, you feel them kind of similar to the unit tests. We try to have some unit tests for the tools and unit tests for the trajectory, the use of the trajectory, etc. And the final one is evaluating the final response. So does your agent achieve its goal that we defined at the beginning? For example, answering a question, or creating a summary, or doing the X action, if you want. And all what we tried to talk about, it was not automated. We can automate those steps if you try to find or to add an LLM into the loop of the evaluation. And this is what we call the autorator. So this LLM is going to act like the human inside the loop, if you want, of the automation. So since there is no ground truth, it's crucial to precisely define what success look like for you. It depends on your use case. Sometimes one success measure is different from let's say field to field. It depends on the precision. It depends on your goals from this project, etc. So we try to adapt them to the standards of the projects. So here we said that since human is always in the loop of evaluation, so sorry, my voice is not here anymore. So we will find that the automated metrics are not enough. The human always should assess this evaluation, since we said that there is many things that are not set into a default, let's say, metric. So let's move directly to the next one. We will find three main techniques. It's either human evaluation. The method is a human evaluation. So the strength of this method is that we will capture any wrong behavior. We will consider that the human is the factor. But for the weakness, it's time consuming. And we, in production settings, let's say, we don't have a person that is here always to assess the working of your agents. That's why we move to one of those techniques. It's either an LLM as a judge, or or an automated metric. So an LLM as a judge is going to be something scalable, efficient, and consistent. But if you have kind of limited resources, or you are not really taking control over your big system. So it can look overwhelming. However, the automated metrics, which are just some KPIs that we make sure that we are okay with them, and then we try to consider them for our system, they are more objective, scalable, and efficient. Of course, they may not capture the full capabilities, but kind of something stable that we can rely on. Cool. Now that we finished with the evaluations, we will try to look on some best practices for AI agents in production. The first thing that I'm going to talk about is code like a pro. So basically, it's a new field, and people are coming from different background to learn it. So, but when you will find yourself in a production, and especially if you are from computer science background, you need to code like a pro. So you need to have a clean code if you want, clean project structure, a modular structure, testable code, not only kind of small notebooks if you want. And I'm saying this for people who are trying to learn this field. So try to learn how to organize your work, how to organize your projects. For example, how to structure your GitHub repo, etc. So it's really essential, and it will help you to share your work with coworkers and to make your agent or system scalable. So easy to be scalable. For example, here it's one of the simple repos that you can consider for your projects. For example, you have those the README, the requirements, the PyProjects, the env, etc., where you put all your dependencies, the API keys, etc. You have the docs. It's really interested to document your work. Now, to be honest, you can use ChatGPT. It's going to help you to document your work and keep track of what you are doing. To explain, for example, what are your tools, what is your logic in the, for example, the search logic inside. What is the technique that you are using, for example, to implement your data storage, etc. You have your scripts, the scripts that you use for testing, or for example to run your workflows or your pipelines, etc. Your prompts, it's really interesting to keep track of your prompts. Your unit tests, the tests that we were talking about them just before. So the unit and the integration tests. Sometimes if you are using some APIs, it's interesting to do some small tests here to just make sure that your code is well organized and it's scalable and it's working. Now here for the source, we try to keep our logic inside the source. So here you have, for example, a core for your agent's logic. You put there your tools, the memory, the models, etc. And the pipeline here. If you are using, for example, only one agent, so you may have a simple pipeline, but if you are using multi-agents, so you can have some complications. So it's going to be interesting to get the pipelines outside of the core, the integrations as well. If you are integrating your agent into WhatsApp, for example, or you are pushing it into an application or something like that, and your configs, of course. The second thing is the tool orchestration. So we said that tools are essential for enabling the agents to interact with the word and to execute the complex tasks, etc. So they are really significantly in implementation, accessibility, and capabilities, etc. So understanding this distinction is crucial for us. Basically, we can categorize the tools into three main categories, especially if you are working in a cloud-based environment. So we have the code functions. So we said that they are just the normal functions that we know. We have private REST APIs. So here, for example, if you are working in a cloud settings, you have some internal APIs that you can call. So this is what we mean by the private REST APIs, and the public REST APIs are just the public APIs that you can call. So here we need to pay attention to the latency. I mean, those features are the features that we need to pay attention into them. And when you go to monitoring as well, so you will be interested to check them as well during the monitoring. So here we have the latency. For code functions, it's very low because it's code-based and it's inside your system if you want. The private APIs are medium and the public APIs are potentially high. It depends, especially if you are using some free trials, etc. But if you go maybe for the paid versions, it's always better. Of course, we take as well into consideration the latency of the network, etc. Here, for the implementation, generally, I mean, they are easy to implement, even the private ones. They said it's medium, but it's not something really to talk. I mean, a topic that we need to talk about. The control as well. So if you have something, let's say private, it's always easy to control compared to the public ones. For the authentication, for the public APIs, generally we need some API keys. Here you need to make sure that you are respecting the authentication standards, etc. So you will keep using the same standards that you were using before in any development setting, I would say. For the shareability, for the APIs are more interesting compared to the code functions. However, you can always have your utils, and then you can use them for many other projects. Let's say we have the monitoring. For the monitoring, here we always have a problem with the public APIs because it's limited. You don't have a good or a big options to monitor those APIs. It depends on the provider, and for the version control, it's of course it's generally we are using GitHub, so it's something in the repositories and in your workflow if you want. For the security is something that an issue that we are dealing with. So basically, for example, for the public APIs, when you send some sensitive data, you need to be aware that you are sharing your own data. So here you need to be aware about this and maybe do some small encryption of the sensitive information. For example, let's say I'm sending some billings and I want to get some information from those or some invoices. So inside the invoices, we have your credit card information, you have your own information, you have the address, all those information, you are trying to send them into the API. So here you need to pay attention. And one of the techniques that we are using at True Labs is to try to encrypt the sensitive information, or at least to change them. So it's kind of a way of encryption. So before sending those techniques, you try to encrypt them, and then once you get the answer, you get back your main information. And finally, the internal systems. So the interaction between the tools and the internal system is direct with the code functions at the private REST API. And generally, it's not direct when you use some public APIs, because you are going to go through the extensions. But yeah, I mean, it's something manageable. Now we move to the observability and the memory. So here, basically, when we talk about the observability, we refer to the ability to gain insights into our agent's internal working and the interaction of this agent with its environment. So we are trying to find some tools to do this monitoring, if you want, the internal monitoring of the working workflow. To achieve this observability, we have some tools that are trying to be developed. One interesting tool is AgentOps. So basically, AgentOps will give you a lot of, maybe I will share with you AgentOps just later after the presentation. It's going to give you a lot of I've been accessing to a lot of KPIs, a lot of details about your workflow, etc. It's, I mean, there is a paid version, but the free version is interesting as well to test. So you can test it to monitor the workflow of your system. For the memory, generally, we use memory to keep track of many things inside the agent. For the short-term memory, it's gonna be kind of an archive or an archive for your discussion, or the discussion inside one session. So you can implement it in many ways. It can be just some logs. It can be a cloud storage or a database. It can be an API session, or a combination, for example, between logs and a database. So it depends on your interest. But I mean, since it's something small, so you have a large choice. For the long-term memory, so generally it will try to keep track of the knowledge of the agents. So the knowledge that we are assessing from the tools during the work of the agents, or the knowledge that we are trying to deliver each time. So we keep track of both of them. So it can be a database, it can be a metadata storage, it can be a cloud storage, or combination between them. Yes, that was a quick thing from everything about AgentOps, about agents in production. If you have questions, I'm happy to answer them. And if you want to discuss in details one of maybe the topics that we talked about here, we can discuss them as well.
So firstly, I want to thank you so much for this amazing presentation. It was clear and impactful and so interesting. So yeah, thank you. And then nextly, I have two questions to ask. The first one is when you talked about like implementations of these AI agents, I wanted to ask like what are the trade-offs between like embedding based retrieval system, like RAG systems, and structured symbolic memory? Like what are the pros and cons of using one or the other? Like is there a preference in some fields in the production? So yeah.
So if I understood you well, you are asking, for example, if you have a use case, when to use the RAGs and when to use the AI agents, right?
Yes.
So basically, I would say it's always depending on the use case. Let's have, for example, let's have an example. If you have, for example, you are working on something that will suggest for you a plan for a trip, let's say, okay, and here it's something on real time, and you will be interested to have detail, I mean, insights about the weather, about the price of the flights, something like this. So here you will be more interested to have tools or to add tools into your system, you see. So here you will go more into something agentic. If you are interested, for example, or the use case is a chatbot or something like this, I mean, you want to retrieve some data or your knowledge from an existing database without an extension or an outside extension, then here you can keep it simple and you go for a RAG. You say that you see the difference. So it depends on the use case. Do you need some external tools? If you need them, you can make it bigger and you use an agent. If it's just something, or if it's just a persistent database, you can go with a RAG.
Okay, thank you. Then, talking about memory extension and persistence, my second question was like, how do you manage context limitations and memory persistence for agents that need to recall post interactions or states? Because like long-term memory management is really a core problem. So I want to hear your opinion about it.
I think I didn't heard you well. It's lagging there. Could
Okay.
you please? Mhm.
Yeah. So I was saying, how do you manage context limitations and memory persistence for agents that needs to recall post interactions or states?
So from let me think about it. For example, you mean you have your memory, and the problem is about the managing the context. I think I didn't got follow your question.
Like when we're working with agents, like for example, vector databases or databases. Yes, of course, not all informations are stored in the
Yeah.
database, but like
Mm-hmm.
is are those information that are stored not doesn't form a problem in the future, like in the long term memory.
You mean if the database is going to explode, for example, or our agency is going to be biased by those information, right?
Yes, this kind of question. Yes, kind of
Yeah.
overfit.
So basically, the thing about the database explosion, that's why we are trying to divide between short-term memory and long-term memory. In the short-term memory, we try to keep track of the let's say the short-term discussions, and then one of the techniques is to synthesize this discussion into the long-term memory. So it's kind of a cache, and we will keep this cache for a certain period, I mean, in production. So we are not going to keep the cache for long term. But are we going to throw this knowledge? No, we try to synthesize this knowledge and then to send it to the long-term memory, if you want, or the persistent memory. So this is a way to organize your database. And the other question was, are we going to be biased by the knowledge inside? Right.
Yes, yes.
So I mean, it's I would say it's the same question that we had when we were dealing with the RAGs, but I think now we are trying, especially in the evaluation, we are trying to put some standards for our agents to just, especially in the prompts, to go straight forward to the objective. It means we are trying to monitor this agent to always go straight forward to the objective and to not take things out from the outside of the topic, you see. So here, I mean, or I think that you need to work more on the monitoring and the evaluation of your agent to make sure that you are not going to be biased by either the information that you get from the tools, the external information, or the information that you have in your database.
Okay. So once again, thank you
I
so
hope
much.
I answered your question.
Yes, you answered greatly those two questions. And lastly, I want to thank you last time for being with us for this hour. And it was an amazing meet. And hope we will meet again in some future events, inshallah. Yes.
Inshallah. Thank you very much. Thanks to School of AI and all the working team. You are doing an amazing job. And I wish you all the best.
Yes, thank you. So this ends our session of today, and see you for the next session, inshallah.
Inshallah.
Yes.